Hi, fourth graders. This is Miss Milan. Today is Wednesday. It's May 11th. Today we're going to have a shorter lesson, and we're going to be talking about something specific today that has to do with fractions. Okay, so we've been learning how to add fractions with like denominators. That's been our learning objective for the past few days. Okay, so say that I had two fractions that had the same denominator, and I want to add them together. So say that we had 3/4 plus, actually, let me try this. 3/4, let's try this. I want to make this a little bit bigger. Say I had I didn't pick a good one. Say I had, I'll try this, 3/6 plus 2/6. Okay, we've learned how to show this in a model. So I could take a whole, split it into 6, represent 3/6, and then 2/6, and combine them. We also learned how to add on a number line. And we also learned a very efficient way to solve this is simply to add the numerators up together. So 3 plus 2 gives me 5, and keep my denominator the same. Because really what you're doing here, and we've talked about that in the last lesson, is you're not changing what you split your whole into. You're just combining equal parts. So our denominator stays the same. Okay, so we can say that 3/6 plus 2/6 gives me 5/6. Okay, but sometimes you'll notice that when you add two fractions together, say that I did, or I had something like 3/4 plus 2/4. Sometimes you'll notice, we'll say that you add the numerators together, 3 plus 2, what does that give you? 5. And then my denominator stays the same. Sometimes, in some special cases, you'll notice that when you add fractions with like denominators, that you will end up with a fraction here where the numerator, or the top number, is larger than the bottom number. These are special types of fractions that we haven't talked too much about. So today we're going to learn that these fractions are called improper. This would be an improper fraction. And what an improper fraction is really a fraction that is greater than 1. So sometimes we have fractions that are greater than 1, and that actually can represent a large number, right? So today what we're going to learn is not only what an improper fraction is, but also when we have these special cases and we add these fractions with like denominators together and we end up with an improper fraction, what is it that we need to do to write this in the proper way? So we're going to start today with watching a video. And I'm going to, I'm going to share, stop sharing my
pieces, which are each of 4.
Sorry guys, I'm going to stop sharing my screen with you here, and I'm going to share Khan Academy. And we're going to start with the video today where they teach us a little bit more about what to do when we end up with a mixed or an improper fraction.
Write 7/4 as a mixed number. So right now it's an improper fraction. 7 is larger than 4. Let's write it as a mixed number. So first I'm just going to show you a fairly straightforward way of doing it, and then we're going to think about a little bit about what it actually means. So to figure out what 7/4 represents as a mixed number, let me write it in different colors. So this is going to be equal to, the easiest way I do it, you say, well, you take 4, you divide 4 into 7. So you divide 4 into 7. 4 into 7. So 4, if we're dealing with fourths, 4 goes into 7 a total of 1 time. 4 goes into 7 a total of, let me do this in another color, a total of 1 time. 1 times 4 is 4. And then what is our remainder? 7 minus 4 is 3. So if we wanted to write this in plain, well, let me just do the problem, and then we'll think about what it means in a second. So you see that 4 goes into 7 1 time. So you have 1 whole here. You have 1 whole. And then how much do you have left over? Well, you have 3 left over. You have 3 left over. And that comes from right over there. That is the remainder when you divide 4 into 7. 3 left over, but it's 3 of your 4. or 3/4 left over. So that's the way we just converted it from an improper fraction to a mixed number. Now, it might seem a little bit like voodoo what I just did. I divided 4 into 7. It goes one time, and then the remainder is 3. So I got 1 and 3/4. But why does that make sense? Why does that actually make sense? So let's draw fourths. Let's draw literally 7/4. And maybe it'll become clear. So let's do a little square as a fourth. So I'm going to do it, let's say I have a square like that, and that is 1/4. Now, let's think about what 7 of those mean. So let me copy and paste that. Copy and then paste it. So here I have 2 1/4, or you could say I have 2/4. Now I have 3 1/4. Now I have 4 1/4. Now this is a whole, right? I have 4 1/4. This is a whole. So let me start on another whole. So now I have 5. Now I have 6 1/4. And now I have 7 1/4. Now, what does this look like? So all I did is I rewrote 7/4 or 7 1/4. I just kind of drew it for you. Now, what does this represent? Well, I have 4/4 here, so this is 4/4. This right here is 3/4. Notice 7/4 is 4/4 with 3/4 left over. So let me write it this way. 7/4 is 4/4 with 3/4 left over. Now, what is 4/4? What is 4/4? 4/4 is one whole. So you have one whole with 3/4 left over. So you end up with 1 and 3/4. So that is the 3/4 part, and that is your one whole. Hopefully that makes sense, and hopefully you understand why it connects. Because you say, well, how many wholes do you have? When you're dividing in the 4 into the 7 and getting the 1, you're essentially saying how many wholes? How many? So the number of wholes, or you can imagine the number of whole pies, and then how many pieces do we have left over? Well, we have 3 pieces, and each piece is a fourth, so we have 3/4 left over.
Okay. So I'm going to share my screen with you here. So we're going to do a few practice problems together today because this is something we do need to know if we end up adding fractions with like denominators and we end up with an improper fraction. We always want to change that improper, and I shouldn't say change because you're not changing it. You always want to rewrite that improper fraction as a mixed number. You want to pull those wholes out and represent them. So say you were adding some fractions together and you got a total of 5 halves. Well, I know this is improper because my numerator, my top number, is larger than my denominator, my bottom number, right? 5 is larger than 2. So what this means is that I have a fraction that's greater than 1. Okay, and that means I need to write this as a mixed number. So I'm really thinking about how many wholes are in this fraction. So what you might start off by doing, and what I like to do, is I'm going to represent this in a picture. Okay, so I'm going to have a whole, I'm going to draw a whole, and what I'm going to do is think about my denominator. Well, what have I split my whole into? I've split it into halves. So I'm going to take that whole and split it down the middle into halves. Okay, so how many halves do I have here? Well, right here, what I'm looking at is that I have 2 halves, but my fraction that I'm working with is 5 halves. So guess what? I'm going to need more of these. So I'm going to take this and copy it. We'll see if this works. I know he did this in the video, which was kind of cool. So I'm going to take this, and copy it. Oh no, and what I'm going to, oh, there we go. Okay. And then what I'm going to do is see how many halves I have now. I'm trying to represent 5 halves. Okay, so when I look at my picture now, I see 1 half, 2 halves, 3 halves, 4 halves. But I want to represent 5 halves, so that means I'm going to need 1 more half. Okay, do you guys see the 5 halves here? Okay, so we have 1, 2, 3, 4, 5 halves. Now when I look at the model, when you guys look at the model, I want you to notice, well, how many wholes do I have here? Well, I have 2 halves in this first circle, and 2 halves is equivalent to 1. So this first circle really shows 1. The second circle shows another 1. right? And then I'm left over, I have a half. So we can say that 5.5 is the same thing, or it's equal to, how many holes are in there? 2 holes. And how many holes are left over? 1/2. So 5/2 is the same thing as 2.5. And there's another way you could do this as well, and it's using division. So what he did in the video is, because that's really what you're doing, is you're dividing. You're thinking about how many halves go into this improper fraction, right? Or how many holes can I pull out? So what he also did here is he took 5/2 and he divided it. He said, okay, if I have 5/2, I can do 5 divided by 2, right? And I can think of, okay, how many times does 2 go into 5? How many groups of 2 can I pull out of 5? Well, I can pull out 2 groups of 5. 2 times 2 gives me 4, and I'm left with 1 left over, right? So you could represent 5/2 as, how many times does the denominator go into the numerator? Well, 2 goes into 5 twice, right? And I will have 2 times 2 gives me 4. I'll have 1 left over, and my denominator stays the same. So that's another way that you can solve this as well, is by using division. Okay, let's see if we can try a new one. So say I had 6/3. Okay, I'm going to draw my model. So I'm going to do here. Oh, you know what? I'm going to use squares because thirds are not easy to show using circles. I mean, I could, but I don't prefer to. Okay, so I'm going to take my whole and I'm going to divide it into thirds. 1, 2. Okay, so here's my whole. I've divided it into thirds. I can label each of these 1/3. Oh, you know what? I forgot I wasn't using my pencil. Okay, so this is 1/3, this is 1/3, and this is 1/3. Okay, so how many thirds do we have here? We have 3/3. And this improper fraction, I'm trying to show 6/3. So I'm going to make a copy, and we're going to see if this one works out a little bit better. Okay, there we go. Okay, so now I have 6/3, right? I have a third here, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Okay. So I want you guys to notice when you look at the model, how many holes are in 6/3? Well, I know that 1/3 plus 1/3 plus 1/3 gives me 3/3 here. And I know that this over here, 1/3 plus 1/3 plus 1/3 gives me 3/3. So really I have 3/3 and another 3/3. Well, what is 3/3 the same as? 3/3 is the same as 1. What is 3/3 the same as? 1. So really 6/3 is the same thing as 2. And there's no remainder left over. I don't have any thirds on the side here that I need to include in that. So we can say that 6/3 is the same thing as 2 wholes. Okay, we're going to try one last one together today. So say you're adding fractions together and you have 7/4. Okay, this one I'm going to try without a model. I'm going to try it using just division. Okay, and you can do this 2 different ways. I'm just going to think of this in my head, and I'm going to think of, okay, I'm going to think about my denominator, my bottom number. This is what I'm splitting my whole into. And I'm going to think about, okay, well, how many times does 4 go into 7? How many groups of 4 can I pull out of 7? Well, I know, and what I just realized is I think this is the same exact one he did in the video. So let me change this real quick. Let me do 9/4. There we go. Okay, so how many groups of 4 can I pull out of 9? How many times does 4 go into 9? Well, I know 4 goes into 9 twice. Okay, so 4 times 2 gives me 8. And you could even do this way. You could do your little division on the side, right? How many groups of 4 can I pull out of 9? 2. 4 times 2 gives me 8. Multiply and subtract, and I'm left with the remainder, right? Okay. So now when I go back over here, I'm thinking, okay, 9, how many times does 4 go into 9? You're going to divide. It goes in twice. And then I need to think about my remainder. So what is left over here? Well, we have 1 left over. But remember, what did we split our whole into? What is our numerator, or what is our denominator in this improper fraction? Well, our denominator is 4. So we need to include that when we convert or rename an improper fraction as a mixed number. So we can say that 9/4 is the same thing as 2 with 1/4 left over. Okay, there's a lot of fourths in there, so we can rename that. Okay. So what I'd like you guys to do is make sure that you log or you go back onto the distance learning website. Today what we did was we learned how to rename an improper fraction this is an improper fraction, right? It's when the numerator is larger than the denominator. We learned how to rename an improper fraction into, sorry about my handwriting. It's really hard to write with my fingers sometimes. So we learned how to change an improper fraction into a mixed number. And if you are adding fractions with like denominators and you notice that you have an improper fraction as your answer, you always want to change or rename that improper fraction as a mixed number. And you can do that through dividing, or you can do that through drawing a model.